So, as I showed previously, it's relatively easy to twin in an FCC structure. And just to recap, I'll just show you, we have an FCC structure here. There's a 1-1-1 close pack plane on the horizontal plane here, and then there's a 1-1-1, another 1-1-1 plane here. And when we twin, we just simply shear by a Shockley partial, a 1-1-2 Shockley partial on each plane. Successive plane, 1, 2, 3, 4. And that, in doing so, we've moved the 1-1-1 plane to another orientation. So I'll move it back now by shearing back again. And we get our 1-1-1 plane back. And the twinning operation moves the 1-1-1 plane from this orientation to that orientation. It's about 36 degrees, something like that, 35 something degrees. So, but what about hexagonal close packed material? If we consider a hexagonal structure and we think about the same kind of close packed plane as we have in an FCC, so instead of being the 1-1-1 plane in an hexagonal, it's the basal plane in the FCC. So let's first make our hexagonal crystal. And we make the hexagonal crystal by we can do that by a martensitic shear. So we start with our ABC stacking of our FCC structure, and now if I move every second plane by one partial, like that, I've now created my hexagonal close packed structure, which is A, B, A, B, A, B stacking. So now that I have my hexagonal structure, and this is the prism 1 plane, the 1/1-0 plane, can I twin? Well, I can certainly shear the first layer of atoms here in that direction. But if I try and move the second layer of atoms, this one, they're actually, they have to ride over, if I go in the same direction, they'd have to ride over another atom on the plane below. So basically you can't do that. It's prohibitive, it's energetically prohibitive. So if I start on the one plane, I can move the first plane, can't move this one, but I can move that one, which is the alternate plane, every other plane. Can't move that one, push, can't do it, but I can move that one. And in so doing, I've created my FCC structure. So that's the martensitic transformation going from the HCP to FCC. And it also demonstrates that you can't twin on a basal plane in a hexagonal close packed structure. If I tried, I can't twin. Twinning requires that you can shear in the same direction on each successive plane, and I can't do that. It's just, it's energetically unfavorable to move each successive plane by the same partial vector. And as I'll show you in following videos, if it's a non-basal plane, this is the basal plane, if it's a non-basal plane in the hexagonal structure, especially if we look at some of the more close-packed non-basal planes, it is possible to twin.